Hello. So today is Monday, tomorrow is Tuesday, tomorrow is our final test on sequences and series, etc. And it's a small one, so don't stress out about it. It's only one learning target. And you'll have to show your work. So just like I am demonstrating here, and let's just do a quick review. I've got some problems here. One type of problem is going to be on definitely expanding binomials. So this binomial raised to the fifth power, we should know by now that when you multiply this all out and simplify, you would have 6 terms. You always have one more term than the power. And Pascal's triangle helps us out. So the row that we need is this one. This is the only row that has 6 numbers in it, and the second one is a 5, which matches this right here. And then it's a matter of using it, and you have to show work. I mean, here's the final answer. You could just Google it and find the correct answer, but that's you're not the curriculum isn't about about that. So can we use Pascal's triangle and use some math to simplify? The first one is the Pascal number 1 from here times the a term raised to the 5th power. So 3x squared raised to the 5th. And then on and on, this 3x squared is going to get smaller and smaller and smaller. It's going to be 3x to the 4th, and then it's going to be to the 3rd, to the 2nd, to the 1st, and then it's not even going to be here. The second term is the second Pascal number 5 times the a value to the 4th times the b value, negative 2y, to the 1st. And then negative 2y is going to increase in power. It's going to be negative 2y to the 2nd, negative 2y to the 3rd, to the 4th, and to the 5th. Here's that final one, negative 2y to the 5th. So this is all the work that you are showing. You're showing me this. Again, just being presented with this and jumping down here is a 0. So you got to show the work. And then now we simplify. So here I want to see work again, because people get confused here. They see this symbol. This is a negative sign, not a subtraction. So it's negative 2, not minus 2y. And there are only 6 terms here. So you will notice there are 6 blue boxes. This first one, 3 to the 5th and x squared to the 5th, gives you 243 times x to the 10th. Here, I'm going to do exponents first. You have to. So 3 to the 4th is 81, and it's just 5 times 81 times negative 2, which gives you negative 810. And this one, 3 to the 3rd, negative 2 to the 2nd. So 3 to the 3rd is 27. Negative 2 squared is positive 4. So you've got 10 times 27 times 4, which is this. And then on and on you go. So following order of operations, it's a 2-part thing. The first part is setting it up correctly, which is what is new. That's the honors pre-calculus part. And then the second part is obeying the order of operations to get to the final polynomial. And then sequences. There's a lot with questions with sequences, and to cover them all would make this video too long. So look to your notes, and your homework covers everything. So I've got 2 examples for us. Find the 703rd term of this sequence. There are 4 terms in this sequence. We need to find the 703rd. Well, let's recognize that to get from one term to the next, to the next, to the next, you're always adding 3. So that means it is arithmetic. And if it's arithmetic, you can write out in explicit form. The first term, negative 80, plus the common difference 3 times n minus 1. This is called the explicit form. And you want to find the 703rd term. So you know that n is 703. You want to find the 7. This is how you write the 703rd term. But what is it? What is that value? So you replace n with 703. And you see how I'm showing my work. Simplify, simplify, simplify. 2026 is the 703rd term of this sequence. This is a sequence. Does it converge or diverge? Which means if you were to take the limit of this sequence as n approaches infinity, will you end up writing the same number over and over again? Or will this sequence approach infinity or negative infinity, or will it always be bouncing back and forth between two numbers? So this brings us back to our unit 2 when we talked about rational functions. When n gets really large, the numerator what really dominates is in the numerator, the 3n dominates the numerator, and the 7n dominates the denominator. So when n gets large, the only thing that really matters is it's 3n divided by 7n. 3n divided by 7n. And those n's cancel out, leaving you with 3/7. So the mathematical word is it does converge, because converge means it approaches a real number, like on the number line. And it converges to the number 3/7. So if you were to write this sequence out, many, many numbers in, eventually you would just be writing the number 3/7 over and over and over and over again. Series, again, same thing with sequences. There's lots of ideas with series. Look at your notes and the homework and you should be fine. So find this sum. The sigma means sum of this sequence from the 8th term all the way to the 12th term. Again, this is the correct answer, but correct answers are important, but how do I get from here to here? So that's showing your work. Please, please, please. So you want to replace k with 8, and then with 9, and then with 10, and then 11, and then 12. So that's 5 terms, and then you just add them all up, because that's what the sigma means. So here I am showing my work. You replaced k with 8, 9, 10, 11, 12, and then the rest is just following the order of operations correctly. So 8 minus 5 is 3. Well, 2 to the third is 8. I hope no one is doing negative 9 times 2 and getting negative 18. That would be disaster. It's 2 to the third first, which is 8, and then negative 9 times 8 is, of course, negative 72. 9 minus 5 is 4, and then 2 to the fourth is 16. And then, lastly, negative 9 times 16 gives you negative 144. So you end up getting 5 negatives. You add them all up, you get negative 2,232. Last question. Find the sum of this series. So here, we don't know how many terms there are. We know we're adding. Those are the two. Well, so we know we're adding, but we don't know how many we're adding, and we don't know much. So let's investigate. How do I get from one term to the next? It looks like I am subtracting 7. So that is called a common difference, which means it's arithmetic. And the common difference is negative 7. So since it's an arithmetic sequence, I can write it just like this, where I have the first term plus the common difference times n minus 1. So the first term is 8, and the common difference is negative 7 times n minus 1. And then you can simplify this. Your test is going to be on My Math Lab. It always asks to simplify. So distribute that negative 7, combine like terms, you get this. What is it asking? Find the sum. Well, I need to know how many things I'm adding. So what term is negative 412? Is it the 20th term? Is it the 30th term? What is it? So I use this formula. I'm going to replace an with negative 412, and I'm going to use algebra to discover what n is. So you subtract 15, divide by negative 7, 61. So this negative 412 is the 61st term in this series, the 61st term. So when it says find the sum, I'm adding 61 numbers. Now, instead of going to your calculator and typing in 61 different numbers and then adding them all, I don't want you to do that. I want you to realize that we can use this formula that we got from Gauss. And this is the number of terms divided by 2, so 61 divided by 2, times the first term plus the last term. And then once you get here, again, it's just order of operations. These two add up to negative 404. You multiply by 61, you divide by 2, and you get negative 12,322. So if you were to add all these numbers, of which there are 61 of them, you would get negative 12,322. I hope that was helpful. Good luck tomorrow. You're going to do great.